Okay, the next chapter that we do, in the book, it's chapter 6. Chapter 6 is, the same author that wrote our functions book, wrote our pre-calculus book. And that's chapter 10 in that book. It comes after all the trigonometry. It's actually at the very end of the year. And, whoever put together this curriculum downtown, they're trying to fill space for us now in between now and the second semester when we do all the trigonometry. So they've moved what is generally a fairly difficult chapter up to this part of the year. And we don't have to get everything out of this chapter that the pre-calculus people do, right? Because we assume we'll take pre-calculus next year and go into depth in more of this stuff. But there are a few things that we need to do. Completing the square is something that comes up over and over again in this chapter, in this book, in the pre-cal book. It actually is part of Algebra 2, but if you saw it at all, it probably wasn't very much, and you probably didn't master it. Today we're going to do that a little bit. We'll talk about this chapter is actually called Topics in Analytic Geometry. We'll talk about what that means. We'll talk about the first of what we call the conic sections, which are including circles, right? And then we'll talk about this process of completing the square. Z, head up or sit in the corner, okay? I'm not looking at this all day. Understand? Because we do need to do that. We may have avoided it at other times. We're not avoiding it now. We really need to do. You need to know how to complete the square. It's not that hard. So we're going to do that. That is what we're going to try and do today. And it's not really the first section of this chapter. The first section of the chapter actually requires some of the trigonometry that would have been taught before that we didn't do. Okay. So this is kind of cobbled together. The circles part actually comes from the very first chapter. It's like page 35 or something like that. Okay. So this chapter, again, is called Topics in Analytic Geometry. Now, that sounds complicated, but analytic geometry is this. Before about the 1600s, math was mostly geometry, right? This is a quote from Galileo. It's the thing that's on that poster over there, but you can't read what's underneath. My daughter made that up. Anyways, it says, Galileo says, philosophy is written in this grand book, the universe, which stands continually open to our gaze. But the book cannot be understood unless one first learns to comprehend the language and read the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures without which it is humanly impossible to understand a single word of it. Without these, one is wandering in a dark labyrinth. So up to that point, they certainly knew about circles. I mean, Galileo's late 1500s, early 1600s. I mean, all the things that the Greeks did and everybody, all that stuff has been done. They know this stuff, right? They can tell you that a circle is the set of all points, right, which is the same distance from a center point, okay? What changes in the 1600s is Descartes comes along and says, let's make up this thing called the coordinate plane. And the coordinate plane, every point in the plane is going to have an address, right? The first coordinate of it will be the x value, and the second coordinate will be the y value. And now when we talk about a circle, we can not only draw this circle, which has got a radius of 3 right there in the coordinate plane, we can write an equation for it, right? The equation is x squared plus y squared equals 9. That's what changes in the 1600s because of Descartes. And actually, you call the coordinate plane is called the Cartesian plane. Those are called Cartesian coordinates, the x, y. So these topics in analytic geometry are all like making equations out of geometric shapes that were understood before that. But we couldn't do it. We couldn't do any of this stuff that we do with functions, and that is a result of Descartes making the coordinate plane. So the conic sections, or conics, right? I'm used to hearing it conic sections, but the book tends to say conics, right? are these four shapes: circles, parabolas, ellipses, and hyperbolas. Right? We know circle, something like that. A parabola, we understand it to be mostly like a U shape. An ellipse, how would you describe an ellipse? Yeah, it's more oval shaped. It's the circle that's been elongated in one direction or another. Right, that could be an ellipse. And then a hyperbola is like two parabolas back to back. We're going to spend, this is a kind of combination of starting the lesson and doing what I call the way forward, right? The way forward for us here is we're going to spend one day on each one of these sections. Then we have a review. Then we have a test. Right? At this point, it looks like our quiz would be on the 2nd of December. After Thanksgiving, the test would be on the 8th of December. It's a short chapter. All right, Mitch? Right. Now, the reason they call these things conics is because they're made by, as you can see, passing a plane through what they call a double-napped cone. A double, each one, you would recognize one of these things as a cone. But when you put two of them point to point like that, that's called a double-napped cone. If you pass a plane, a flat surface, through the cone so that it's parallel to the base of the cone, then the shape that got traced out right there, that's a circle. Right? If you pass it through just one of the cones so that it's parallel to the side of the cone, then that is a parabola. If you pass it through one of the cones and it's tilted just a little bit so that it's not parallel to the base, then it'll be longer in one direction than the other. That's an ellipse. And then the hyperbola is when you pass the plane straight up and down, so it's going through both cones. It's cutting off a little piece here, or tracing a little trace right there, and a little trace right there. That's the two parabola-looking kind of shapes. Right? That's where the title of conic sections or conics come from exactly that thing right there. So this is a graphic in your book if you were interested to see it. Okay. Now the circle, we'll start with the circle today. The part of this that we're doing today, which is the circle, is absolutely simple, right? There's not really that much to it. The circle is the set of all points equidistant from a point, right? Where that distance, that equal distance, is called the radius of the circle, and that's denoted with the letter R. R for radius. That point from which all the points on the circle are equidistant is called the center of the circle. And we use the coordinates HK to represent the center of a circle. Right. This, what we call the standard form of a circle is this right here: x minus h in parentheses squared plus y minus k in parentheses squared equals r squared. If you remember the first circle that I drew, the one that was radius of 3, centered at the origin, right? That would be like this. It's centered at the origin, so it's x minus 0 squared, y minus 0 squared. And the radius is 3, so it's 3 squared. So that is x squared plus y squared equals 9. have that right? Just a second, I'm going to check back. I had that right. Okay. So at this point, we can't do much with a circle other than we should be able to recognize it in standard form. We should be able to tell what's the center, what's the radius. Okay. Okay, so write a standard form of the equation of a circle if you know the center and you know the radius. Okay, again, remind yourselves, the standard form looks like this. X minus h squared plus y minus k squared equals r squared. Right? So you're going to plug in for h, k, and r. Right? What is the value of h? Right? This is the h, and this is the k, and this is the r. So plug in x minus 1 squared plus y minus 2 squared equals 4 squared. That's just plugging in. Now, I would simplify the right. 4 squared is 16. Seems pretty easy so far. Okay. We good, Mitch? Nathan? All right, same thing. And I'm putting up these examples for a reason, okay? X minus h, I want to look at this standard form. Y minus k squared equals r squared. Okay, and we've already, we know the drill, right? This is the h, this is the k, this is the r. Okay. When you substitute h equals negative 1, right, that is literally x minus negative 1 squared plus y minus negative 2 squared equals 5 squared. And the minus and negative is plus, right? So that is actually, and you wouldn't write the step of x minus a negative 1. You would just write down x plus 1 squared plus y plus 2 squared equals 25. Right? So it's important that when you see a plus inside, that means the h or the k, whichever it is negative. It's kind of like when we use the transformations for graphs of functions, right? When I say y equals the absolute value of x minus 3, that is a shift of 3 to the right. It's not what you think it's going to be, right? So this is telling you that h is negative. Right? If you see if the h and the k are positive, then it's x minus, y minus, right? Because the minus is actually part of the formula, right? So the h and k are positive, right? When the h and k are negative, then it's plus. That's what you see. I mean, this is going to come up for every conic section over and over again. So you don't want to make a mistake on that one fine point. I think there's 2 homework problems like that. All you have to do is just plug in for the h, k, and r. Done. Okay, then the other 2 are going to be more like this. What is the center and the radius given the equation of a circle in standard form? And then sketch the graph. Okay, let's see. What is the hk? Looking at this right here, what would you say is the value of h? Right? If you see a minus in the formula, then it's positive. If you see a plus in the formula, then it's negative. So the center of this circle is 3, negative 4. So I can plot that point, 3, negative 4. I think I didn't even go far enough on this. Darn it. I go to all this trouble to make that. I didn't even set it up right. Okay, now, what is the radius of the circle? Right? Remember, it's the r squared is 36. So r is 6. So in sketching the graph, if you're going to have to sketch a graph, you don't have what is that called? A compass to go around. So you just do the best you can. Make a point 6 to one side, 6 to the other. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then this one's where I go off the scale a little bit. It's right there. And you can draw yourself a circle. And then r equals 6. If you have to sketch these graphs, and obviously there'll be a wide variety of your skill at drawing a circle and making it look like a circle, that's why it's important to label the parts that I can see. So it's, you may have drawn a really crazy looking circle, but if you label the r as 6, then I know you knew what it was. So I think there's 2 problems like this in the homework. You're given the standard form, identify the h, k, and the r, sketch a circle. Easy stuff, right? See, I could have cheated. I could have done this. I could have grabbed my circle right there. I'll go, yeah. There we go. There's my circle. Perfect. It's orange. I can fix that too. Watch. Fill it up with white. Boom. Okay. Okay. So now you don't have to write these down. Okay. Don't bother writing these down. We're going to get to each one of these in time. We've already discussed the first one. This is definitely one you should know by now, which is the standard form of the equation of a circle. These are at least one of 2 standard forms for the other conics, right? Parabola, ellipse, and hyperbola. And the thing you notice about every one of them is they've got something in parentheses squared. They either have an x minus h in parentheses squared, or they've got a y minus k in parentheses squared, or they have both. Every one of those is a place where you could be asked to do this process of complete the square. So that's why we have to we need to go back and spend a little more time on completing the square. Okay. So you can see, notice, and this becomes important when by the end of this, by the time we've done all 4 of these, we'll be able to recognize the conic sections, even when they're not in the standard form, just based on some patterns. For example, we will notice that there's only one of these that only has 1 squared term. Which one is that? Parabola. Right? All the others have 2. Okay. There's only one of these that, as written, has one of the terms is positive and one of them is negative. Which one is that? Hyperbola. Okay. It's actually, if you notice these denominators here, right? These 2 equations are identical, aren't they? Except for one thing, the plus and the minus. Going from a plus to a minus changes from an ellipse to a hyperbola. But they have denominators here, and especially in the case of the ellipse, a does not equal b. A never equals b, which means they have different coefficients. The circle is the one that always has the same coefficient for x squared and y squared. By the end, you should be able to recognize that just by the not in standard form equation. But this is how it comes into play. So I'm going to do one of the complete the square. Well, okay. No, first we're going to talk about completing the square. Complete the square means, we want to turn this thing, these quadratic expressions, they're all quadratics, right, because of the squared, into something squared. And when you can do that with a quadratic trinomial, it's called a perfect square trinomial. The only thing is you got to figure out what do I add into that third position so that I created a perfect square trinomial. right? And there is a process here, a very simple process for doing this, which is, okay, you've got an x squared and you've got a 4x here, right? The 4x is going to be the middle term of the 3 when I've added a number there. You go to the middle term, divide the coefficient by 2. 4 divided by 2 is 2. Square it. 2 squared equals 4. So you put a 4 there. Okay, now look at that expression now, x squared plus 4x plus 4. If you were given that and told factor it, it's a simple quadratic, you would say, what two numbers their product is 4 and their sum is 4? 2 and 2. So this is x plus 2 times x plus 2, which is x plus 2 squared. So we created a perfect square trinomial by adding the right number into that third position. How about the second one? Let's go through the process and try to figure out what do we add into what's the constant that gets added to those first two terms. Remember what you're going to do here? You're going to take half the middle term, negative 3. Negative 3 squared is 9. 9. Right? That last term is always positive because it's the result of squaring, right? And when you square a positive, you get a positive. When you square a negative, you get a positive. And don't let the calculator fool you. If you put in negative 3 without parentheses and square it, it's going to tell you negative 9. Okay, now if I factored that, x minus 6, I would say, what are the factors of 9 that add up to negative 6? You would say x minus 3 times x minus 3, which is x minus 3 squared. Okay, so we created a perfect square trinomial. It's not always the case that when you get to this part here, that it looks factorable. There could be fractions involved, in which case you're going to say, I'm not really sure what I should put there. Note that when you took half of the middle term, you got 2 here, so you got plus 2 there. When you took half of the middle term here, you got negative 3, so you get negative 3 there. So in the end, you don't have to think of it like a factoring problem. It's just going to be x plus or minus whatever that half the middle term was, squared. Now, you don't complete the square if you've got a number that's not 1 in front of the x squared, right? We cannot go through this process if we have a 2 in front of the x squared, right? If that's the case, you have to factor the 2 from the first two terms, right? Okay, so factor the 2 from the first two terms. 2 parentheses, what's left inside? X squared plus 8x, right? Okay, now you can complete the square. Now, where I see a lot of mistakes with this is that you think you're supposed to factor the first two terms, right? If you were going to factor the first two terms, the greatest common factor is 2x, not 2. Don't factor the first two terms with the greatest common factor. Just take whatever that coefficient is. You get way off track if you try to factor out 2x. Just factor the 2. Right. Okay, now let's complete the square on what's inside the parentheses. Half of 8 is 8 over 2 is 4. 4 squared is 16. So this is a plus 16. So this whole thing is 2 times x plus 4 squared. Yeah, I was going to say, I know I've already done this on the next slide. I tend to just make abbreviation, CTS, complete the square, instead of writing it out every time, complete the square. I was in the military. We turned everything into an acronym. We had more acronyms than you know what to do. It comes its own language. So you don't have to do this, but I'm going to just show you. This is a circle. It doesn't look like a circle, but we can complete the square and turn it into a circle like this. Okay. First, like we saw in the standard form, how many times are we going to have to complete the square? Twice. You got the x minus h squared and the y minus k squared. So the first step, and we will repeat this process for every conic section. In fact, we almost don't do it for circles, but the other three, we keep doing it over and over again. Right, this is x squared minus 4x plus y squared minus 6y equals 23. So I got the x terms together. I got the y terms together. I left a space to add a constant, which will complete the square, and I moved the 23 onto the other side. Okay, if I'm looking at just the x terms here, what would I add to complete the square? Half of negative 4 squared. 4, right? Half, remember, the negative 4 over 2 is negative 2. Negative 2 squared is 4, so I add 4. Okay, I can't just add 4 to the left-hand side of the equation because, on the last side, that was an expression. I can do anything to an expression. I can't do that to this. Since I added 4 to the left, I got to add 4 to the right. So because of that plus 4, I have to add 4. Okay, what am I going to add to the y terms to complete the square? I think we did this one. Negative 6 over 2 is negative 3. Negative 3 squared is 9 plus 9. Again, but because I add 9 to the left, I got to add 9 to the right. Okay, again, this x squared minus 4x plus 4, that is x minus 2 squared. Right, this y squared minus 6y plus 9, again, there should be a plus in between these. Y minus 3 squared. And when I add up everything that's on the right-hand side, I get 36. So I just put that circle into standard form by completing the square twice. What is the center of the circle? 2, 3. So the center and what is the radius? And the radius is 6. So for most of our shapes that we do, they give you something that's not in standard form, and they say, put it into standard form and then identify the parts, and the parts are different for every shape. Okay, what we're going to work on, and it actually isn't 100% in line with what we're going to do when we get to the next section of parabolas, but it's the best, it's how most of you, if you saw this before, saw it. And it's the only thing I got things printed out for already that I can give you. So we're going to do the same kind of process. This is a quadratic function, which means the shape is a parabola, which is a conic or a conic section. Right? So we're going to put it into, it's not actually the standard form that we put it into for this textbook. It's what in Algebra 2 called the vertex form. Right. So I know that I need to make a perfect square trinomial, and the way I do that is completing the square. Now, if you might have done this in the past, right, with parabolas by doing h equals negative b over 2a and then substituting that back in. That's not going to work not even for, well, it can work for parabolas. It cannot work for any of the other shapes. So I wouldn't even go down that path. We really need to learn to do this by completing the square. So here's the steps, right? y equals x squared plus 4x. I'm going to put that in parentheses, and I'll leave the minus 6 outside. Okay, what do I add to the x terms to complete the square? Right? Half of 4 is 2. 2 squared is 4, so I add 4. Okay, now on the last one, because it was an equation, I added that number to the other side. This one is a function solved for y. So instead of adding 4 to the left, I'm going to subtract 4 at the end. To balance out adding a 4 here, I subtract 4. Four minus 4 adds up to nothing. Okay, so what perfect square trinomial did I just create? What goes inside the parentheses squared? X plus 2. And at the end, we have minus 10. And we won't worry about the parts of a parabola right now, because when we get to it next class, it'll be a little bit different than that. But this process will work mostly the same. So let's try another one. Okay, again, here's one. You know, what do we have to watch out for in this one that we didn't have to watch out for in the other one? The 4, right? We can't complete the square unless the a equals 1. In this case, it's not. So what do I do to fix that? I factor out just the 4, right? So this is 4 times x squared plus 2x. All right, now I got to complete the square on what's inside the parentheses. What goes in that third spot? Half of 2 is 1. 1 squared is 1, right? Okay, what do I do to balance out the fact that I just added 1? Okay, it's not actually, you don't subtract 1, because that 1 is inside parentheses and it's being multiplied by 4. It's like you added 4. So at the end, you have to subtract 4. Right? This times this is 4. So that together balances. Okay, so now I've got 4, and what is the perfect square trinomial that I just created? Here you go, x plus 1. And then at the end of the line, simplify, minus 8. I think I got one more. Then we'll be done. Okay. How about this one? What do I need to do first? Factor out the 4, right? Y equals 4 times x squared plus x plus 1. Okay, now figure out what goes in the last spot. What is the middle coefficient this time? It's a 1, right? That's a 1. So I have to take 1 divided by 2, right? And then I have to square it, and that is 1/4. So that's where you can get into these things where it's actually not going to be like all integer values, which you can just easily see the factoring of it. Right now we've got plus 1/4. Now what do I have to add to the end of the row, end of the equation, to balance out the fact that I just put a 1/4 there? Uh-huh. So what is 4 times a fourth? Is 1, right? So I subtract 1, right? That balances. Okay, now what is the perfect square trinomial that we just created? We got a 4 in front of the parentheses. And this is where, on all the other problems, because they were chosen quite carefully, you could have looked inside the parentheses and figured out how to factor that, right? You could have figured out how to factor that. They're all pretty simple in that way, right? I use numbers that worked out that way. When it's a fraction, you're not going to think of it as a factoring problem. Remember that what goes inside the parentheses is x plus whatever was the half of the middle coefficient. That's what goes in. X plus a half. Right? Because that was when we took the 1 and we divided by 2. That's what goes in there. Plus 1/2. Okay, now we've got to simplify the end of the row. 1 minus 1 is 0. So that's done right there. Okay, good to go? Janae, are you good? Good. Right, so that's what we did. We're at least a little familiar what we mean by the conic section. Circle, parabola, ellipse, and hyperbola. We know about circles, and we did some practice completing the square, which will help us later. Right, the homework, these 4 are coming from the textbook. They're very easy. They're like the examples I did about circles. It'll take you about a minute to do all of those, right? These are completing the square things from something I have printed out, so I'll hand it to you. I call it a buck slip because I cut it out. In the military, that's what, we had like a little piece of a paper like that, and you hand it out. Call that a buck slip.